As you can see, we're going to talk about water, why we flood. Hopefully by the end of this, you'll have a better feel for that. Let me start with these pictures here briefly. This is 17. This is 17T. So this is the watershed that goes in front of 17 and then between 17 and 18. This is what it typically looks like after around an inch of rain. Heavy rain, admittedly, but an inch of heavy rain. So this is not after 4 inches or 5 inches. Little footbridge here, overrun, bank full, water. We'll see later some pictures where we have over here some damage on 16. The bunker's filling up and sometimes getting on the green. This is 18 pond. This is more than an inch of rain. This is probably a very significant rainfall. But again, I've seen this probably 3 or 4 times since I've been here, where it completely circles the scoreboard area and essentially is, I don't know, 10 times its normal size. This here is to the left of 2. This is the fairway bunker on 2. So this is all the water that sheets across 1 and goes down between the left of 2 and 6. Now, why this happens is basically because we are caught between a hill and a river. By that I mean we occupy the terrain between the hilltop, the TCU, and all the development, all the neighborhoods there, all of the storm sewers, all of the creeks, all of the watersheds that have been there forever that must make it to the Trinity. So they're going to go over, under, through us to get there. There's nothing that can be done about it. And clearly, our flooding problems are getting worse over time as some of the infrastructure and some of the things that were designed for a lot less water are being just overrun by more and more water. More water getting on us more quickly is the problem. So we're going to go through our watersheds and detail, hopefully, the fundamentals of what's involved and why it's becoming more and more of a problem, and then what we need to do, I think, to fix them. We are going to be discussing 2 major areas, one on the front, one on the back. Picture on the left, water backing up at 16 Green from HB1 and Howard's Branch. That is what happens when we get a lot of water. That is 16 Green behind that fan there, which goes underwater occasionally, at least the front half of it does, from 2 creeks that have to get through our property. They are called HB1 and Howard's Branch. We will, after this, have you intimately familiar with those 2 creeks and how they work and how they don't work and how we need to fix them. The middle slide, and then really even the one to the right, is water that enters the front side that enters our property underneath where Colonial Country Club on the right of 1 there is, and is supposed to go under our property, but that pipe is non-functioning, or at least functions poorly. It's way too small. So what actually happens is the water comes up and sheets across the golf course, goes across 1, down the big road, down between 2 and 6, and eventually finds its way into some drains. This picture on the right is how bad it can get. This is water actually coming up through some drains on number 6. Obviously, it's supposed to go the other direction. This is what happens when there's so much pressure behind the drainage, essentially pushing it up. And then this is also something that happens, and we won't talk about this a whole lot because it's technically not a watershed, but it's a problem with our drainage system over on the Putting Green and Nine Pond, where we also have water that comes up and sits now, as you probably know, there between Nine Pond and the Putting Green. All right, this is going to take a little bit of time, but it's really important. Mr. Rushing contracted the services of some engineers to look at our watersheds, among other things. And this is a chart of our watershed that they put together. Here is the golf course outline right here. And then all of this outline is our watershed, or all of the surface water that drains through creeks and storm sewers, however it gets to these tributaries and other areas and goes through and over and under Colonial Country Club to the Trinity. 1,835 square acres, or 2.5 square miles. It's big. This, in a nutshell, is kind of the challenge we have. All of this water enters at three main drainage points. A is HB1. This is 16T. It's probably the largest watershed. It goes through kind of the guts of TCU and kind of goes through the center of this entire area. B, which is called Howard's Branch, little creek here that picks up, I think, mainly just this area right here. So it's piped underneath Mockingbird, underneath 15, underneath 17 to our collection area and then out. And then C, which is the right of one, is I'm calling it Country Club Branch just because it doesn't have an official name and I needed to name it something to talk about it. It's basically where Colonial Parkway and Country Club Circle come together, piped underneath from this watershed here. It goes into a pipe that starts underneath one and goes kind of all the way underneath the bathroom on 5 Green. So this, again, I give some reference points from University to Hewlin, past Granbury, and past even a little bit of Seminary. All of this water has to get through us to the... This is a slightly zoomed in picture, focused a little bit more on what's going on here, specifically with these points of entry and our challenges. So, as we looked at earlier, this is 16T. This is the main part of where HB1 is piped underneath Mockingbird here and gets onto our golf course through this area and into our collection area at X. Howard's Branch, again, comes from the neighborhood here, kind of goes this way, is piped underneath Mockingbird into a head wall right here, and then is piped, as opposed to this is all surface, as you know, it's a creek. This is piped underneath to the collection area and then out. Country Club Branch is this little creek here. It's piped underneath. And again, this is kind of the route of the piping. Slightly different. It actually goes more of a straight line like this. Here's one I didn't talk about. This is just a kind of a, but it's significant under heavy rains. There's a similar little watershed right here. It's not very big, but it collects enough water that goes underneath, and it just kind of is daylighted out here on the golf course. And so on heavy rains, it picks up enough water where you get a lot of water here that normally you don't, because all the water, even when it gets on the surface, sheds kind of like this and out. So this does need to be connected to this as well. So we'll call that Country Club Branch 2. That's a minor thing, but it needs to be addressed. So this carries the bulk I indicated before, the bulk of the water that goes through kind of the center of TCU and a lot of things. A lot of water comes through here. Even in the 12 years, 13 years that I've been here, it is apparent to me that more and more water is getting into this watershed. And even with an inch or two of heavy rain, this gets full really quick. Howard's Branch, I would say it's a little bit harder to know because you don't see it. It just kind of shows up here, and it combined with this really amounts to, kind of the totality of the water that then has to go under and over 18 and 10 to get to this creek. But this again is just kind of a review of the entry points and how they have to get out of Colonial. So let's look at the two major tributaries, HB1 and Howard's Branch Creek. Make sure we know exactly where they're going, what they're trying to accomplish, and what our challenges are. Seen this picture before. This is how bad it can be coming in on 16 and how much water backs up on really heavy rains. It occasionally gets on 16 green. This is the front of 16 green. This is just to the left of that. This is the water traveling, here's 16 green right here, traveling over the walking bridge and underneath this bridge and between 17 and 18 on its way to the collection area. Okay. Here's how it travels. Here's where it enters underneath Mockingbird, a very big structure here. All of this is testament to how much water comes through here. I think this work was done in the late 80s or 90s, and it wouldn't be this much rock and this tall had the people designing it not known how much water did come through here, and I think also how much increased water was going to come through there in the future. So it comes through there, it goes down, as you know, kind of from up here all the way down, turns the corner between 17 and 18 in this collection area. Now the collection area is interesting because it's may not know exactly how it works, so let's spend a minute going over it. This part of the head wall, this is the part that is facing 17 and 15. This has two large outlets which go into this collection area. This is the piped area that goes over to Howard's Branch, underneath Mockingbird, into a large head wall where it kind of goes down a little bit and then it's piped into this collection area. So this is all underground from this point backwards. As opposed to this one, HB1, where you see it all. It's all surface drained, none of it's piped. But all of that, theoretically, enters here or here, and then is piped underneath 18 and 10 to the creek over here. So all of this, if you think about 85% of the watershed that we looked at, 2.5 square miles, is somehow supposed to go through this pipe. Ain't gonna work. We all know that. In fact, I don't think this was designed originally to carry all the water. I think everyone knew it was going to surface drain, which is certainly what it does. It's part of why some of this gabion has been put in over the years to help all of the surface water that comes up and goes across. This is a shot just a little bit closer to kind of the 18 part. So it comes up and sheds all along this gully right here, goes by 18, goes by 10, goes underneath this bridge, which is this shot right here, past this bridge, over all this gabion. Here's where you finally see the pipe again, Again, this is the same pipe that starts here. It ends up going kind of underground again through some gabion here, and then terminates right here into the creek itself. And then from here, this winds all the way along 11, goes underneath our little bridges there at 9T, all along the left of 7 and 8. And then here is 8T, here is 7 green, comes out in this large square structure right here and enters the Trinity. So that's the route it's taking. The biggest obvious problem engineering wise is trying to get 2.5 miles of water through this pipe, and that even though it gets up and surface drains, it's not efficient enough, and it backs up and does the things that we showed there on 16 and 17. All right, let's try to fix some things here. Solutions. Start with A. Return the piped area from 1810 to a natural creek watershed so the water can flow through the golf course without backing up. So that is this section right here, between the collection area on 17, 18, as it goes across then into our creek system on the right of 11. This area right here, we would open up, take the pipe out, return this area to a creek again, as it was originally. So the water can get out into this creek here much more efficiently, much more rapidly, to keep things from then backing up in here. Okay. B, this will allow the removal of the unnatural containment mounding along the right of 18 and left of 16. So you've probably all seen this. We have some unnatural mounding here along 18 and 16 that has been put in place over the years to try to keep this water, as it's turning in this creek area, in the culvert area, and not spill out onto the golf course. Now, it rarely spills out onto 18, but it does spill out, as we've shown, on 16, and occasionally fills up this entire basin here. So once we fix the carrying capacity here, and it can carry much more water and get out much quicker, we can take off this mounding here and make it much more natural looking. C, this will allow the 1718 portion of the watershed to be naturalized into a creek rather than the concrete culvert at present. So, as I think everybody knows and will probably agree, this is one of the uglier places we have, where we have a concrete culvert essentially from here to here that carries water and keeps the erosion down, and it does work to do that. But you have in your last two holes one of the uglier, more unnatural areas on the golf course. So from here to the collection area, we take all that out, we reroute it slightly, make it move a little bit, dig it much deeper, and turn it into a creek. So taken together, what we're really doing is from here to here, we are naturalizing this watershed, or renaturalizing it much more like it was before, and making it look better and function better. This is a shot of 1018 pond completely out of its banks. This is about as bad as it ever gets, but as you can see, the island of the scoreboard is virtually gone. This is the big pecan that we unfortunately lost last year, and you see the extent to which this becomes a pond 5, 6, 7 times bigger than in normal times. The other thing we'll talk a little bit about, all this water comes from basically piped underneath the golf course, water that comes from the clubhouse the drainage in our parking lots and things and along Country Club Circle. Piped underneath and terminates in 18 Pond and in 9 Pond, which is connected to 18 Pond. But what also complicates it is this here. It also has a natural spring in it. 18 Pond, we never have to add water to it. It's kind of a constant level, which means that there's some groundwater there that I think is constantly seeping in there. So when we're trying to drain this out, this obviously does not help either. So to quickly review, Watershed D primarily comes from Country Club Circle and a variety of drains that go underneath. And there's one here that goes into 9 Pond. There's a couple not depicted that go into 18, that actually kind of go underneath the clubhouse into 18 here, that we found when we were redoing the wall. Kind of an interesting note, we have, when this building was built and the sewer line put in here, somehow this, which used to take water from 9 into the 1018 pond, was interrupted, and it no longer functions. So some of this water that now goes into 9 Pond, and there's also parts that come up in here, instead of traveling into a pipe into 1018 Pond, are stuck. So we have this phenomenon that's happened for a while where water comes up right here in a large area pond between the 9 green and the putting green in a drain, surcharges up, stays there. So then we have to pump it into 9, and then we have a good drain right here on the left side of 9, where we do that thing, you may have seen it, where we're pumping water out of 9 through some pipes into this drain right here and then out. So we have a number of complications here. Not only do we fill this up, now we did put in, when this first started, the other thing that's happened is there was a drain here that used to drain the water out of 1018 Pond out. It went underneath, or goes underneath, tennis courts and terminates somewhere right here. That's failed in a number of places. It's a concrete drain, and it kind of went like this. We've had it cameraed from this end, and there's just cave-ins all along there. So there's no way really to repair this. This started becoming a problem 6, 7, 8, 9 years ago. So we put in a drain, I'm sorry, not a drain, a pump here. We have an underground pump. We went across with a drain to right here. So when this fills up, a pump kicks on and it drains water through a pipe underneath 10 into the 11 watershed. Now that still works well, but just the capacity, the size of the pump and the size of the pipe is limited. And when this gets really bad, there's so much water in here, it takes a long time for this pump to get the water out. So the issues we have here and why this becomes so bad, a gravity line that has failed, caved in, that used to work and take the water out kind of naturally just through gravity flow, and a pipe that used to carry water from 9 to 1018 Pond that has also been interrupted as well, which causes some havoc here on the 9 side. All right, so how do we fix this problem? 2 things. A, as I indicated before, there's a drain right here that we get water coming up now as the water's been interrupted from its traveling into 9 and then over to this pond somewhere. And in general, we need a new trunk line here on the right side of 9 for a variety of reasons. There's really poor drainage here. Some of this drainage and this drainage doesn't work very well. So we need to put in a new trunk line from here all the way to the watershed here. We'll tie in everything here, the pond, the green, these greens into this, some of the collateral drainage here, problem solved. For 1810 pond, we need to do a new gravity drain. As I indicated, there's old gravity drain right here that used to go underneath tennis and something like this that's collapsed and failed some years ago. We need to establish a new one somewhere, a large capacity gravity drain that basically just has an opening here at whatever level you want this at. Install it across 10 fairway into the watershed, problem solved. We won't need the pump. We won't have to worry about all these things, and we won't have to worry about this filling up with water as long as we make this pipe large enough. All right, we're going to analyze watersheds on the front side now. Again, we're calling this Country Club branch because, to my knowledge anyway, it doesn't have an official name, and where it enters our property, which is right here, this picture right here, is the intersection of Country Club Circle and Colonial Parkway. So you have a 3-foot pipe underneath the road, comes out on the golf course right here. This is the right of one where it enters our property, and then is piped from this pipe going all the way through underneath 1 to between 2 and 6, and then ultimately underneath the bathroom on 5. This is looking at that pipe kind of from the road side, from Country Club Circle side, looking back. This is a 3-foot diameter pipe. This is a 2-foot diameter pipe. So right off the bat, you have a mismatch of a lot more water can enter here than can get out here. The other fundamental problem is all of this pipe from here going to 5 has failed. It's a concrete pipe that has joints in it that over the years have fallen down or eroded or broken, and we have a number of issues to face. But what happens functionally to this watershed is just what's depicted here. And anybody that's been out here in the rain has seen this 100 times. Water exceeds this capacity here, comes up out of this little pond area and starts sheeting across 1. So this is sheeting all the way across 1, goes down the big road, and then curves here as you're going to the driving range. It goes between 2 and 6, and it just kind of sits in that area. All of this just fills up until it can, the drain can clear itself. This drain can clear itself, and the water can start going back into the drainage system. It just takes time, and it takes way too much time. So, how do we fix it? That's what we're going to look at. Let's look at it a little bit more closely. So again, starts here. This is where it enters. This is where it's piped. Very quickly, this pipe capacity is exceeded. It gets full, and it starts sheeting across 1. Happens all the time. Here's where it turns, goes down. Here is the left fairway bunker on 2. So again, this is part of the same stream of water sheeting down. Some of it leaks over because it's a little lower here into this bunker, but this is also some drains. There's one right here that surcharge like this. They actually come up because this pipe capacity is full. So it starts going backwards through the drains because of all the pressure of this pipe going out. This is some surcharging on 6. And this is the other part of the complication to this. This is that same pipe here, the concrete pipe. It's joined in 8 or 10 feet sections. I'm not sure which. I think this was done in the late 60s when the Trinity project was. many of these joints have failed. What happens is at the bottom, they cast down a little bit, they open it up at the top, you start getting this pipe full, it draws dirt into there, you get a sinkhole, we have to find it, cover it with concrete, try to put it back. It's a kind of a never-ending process. What needs to be done? It's not a whole lot different than what we talked about with 10 and 18. We have to add new, bigger infrastructure to handle the water. So first, replace and enlarge the main trunk line from Country Club to the Trinity. So here where it enters, we currently have around a 2-foot concrete pipe that roughly travels like this, goes underneath the bathroom here and terminates in a head wall in the Trinity River Creek. We have to expand this capacity significantly. I don't think we have a number yet. I don't think we have any engineering, but we know, in fact, there may be a route. This route from here to here is actually closer to get into the watershed to the left of 7. But we don't know if that's going to complicate things downstream because the creek here on 7 is not directly into the Trinity yet. It's part of that main watershed that goes, from the left of 11 and et cetera. So it may not be a good idea to put more water in this thing before it gets out right here by 8T. So we'll have to see. Maybe we need to keep it here. But in any case, we need to expand the trunk capacity of that main drain significantly. It just has to be able to carry more water. And then we would tie in all of the collateral drainage. If this is still going to surface drain, there's so much water that comes in here. The pipe size you have to put in here to actually take it all underground and never have it come up would probably be a 5-foot pipe, which is not going to happen. So we know we're going to get surface drainage. We just need to have much less of it. And then if we have a good trunk line, which will take a lot more water out, and then we have new collateral drainage, which is picking up this sheeting effect in here where it just sits, it will take the water out quickly, and then these will take the surface water out quickly, and the problem solved in a way. We're not going to be able to engineer again no more surface water ever coming in here and sheeting across the golf course. I think that's a pipe dream, no pun intended, but we can make it much, much, much better. This is the tie-in I talked about earlier. This just has to be connected here. Right now it just kind of dead ends and just kind of sets and goes in a little surface drainage area and onto this area with really heavy rains. We just need to tie this into C. So we fix this by doing one thing, really: add carrying capacity. We're doing it in 2 different ways. On the backside, for the HB1 and Howard branches, we are opening up, naturalizing that watershed from where we can, somewhere around the left of 16 green for the HB1 and at the collection area for Howard's branch, so that they can carry a lot more water out and get to 11 Creek, which is where our natural watershed currently resides, so that we don't back water up. And on the front side, we increase the pipe capacity to the Country Club branch and the related drainage field around it, so that, again, different method but same concept, we can carry a lot more water quicker, more efficiently from where it enters the property at 1 to the Trinity. And then finally, a new gravity drain for the 1018 pond. So we fix the fact that that drain has failed. make a gravity drain with enough capacity to where all of the water coming in to 1018 pond can be accounted for and goes out and doesn't fill up. And then related the failure on 9 pond, we reestablish that to where it gets to some drainage. In this case, new drainage along the right side of 9, which gets to the creek there at the bridge immediately to the right of 11 Green. So it's not rocket science, but it is really important that we marry up the water coming in to the engineering to get it through Colonial Country Club and to the Trinity without impacting the golf course like it currently does now.